Today I want to talk with you about a very interesting problem, or rather a problem only if you don't know about it. Namely, we are going to discuss used components and how they affect PCB assembly. And yes, I'm making this video for a reason, because one of my clients was a hero, didn't listen to me, and now we had a huge product recall. And because of that, I'm now going to make a little video and I'm going to discuss it. Well, to start the situation, this gyrodrome here, in general, it's a very reliable piece of kit. However, at my clients recently, we had one charge where about 20% of trinkets failed with this gyrodrome dying. And now, of course, the interesting question was, why is this happening? What went wrong? And what can we do about it? To understand how the situation and how the problem takes place, we need to start out by looking at the normal life flow of a PCB. We've got the engineer like me over there. When I was younger, at least I looked like that. And I send the bill of materials and some money to the PCB house. And the PCB house then sources the parts and returns the PCB to me. So this is the normal flow which is done for most PCB interactions. And the components, this is a diagram which I've been basing on the book by Bunny, which I wholeheartedly recommend. Inside of the component cloud, basically there is 4 worlds. There is the genuine new, there is the working fake or the domestic component. Both of these today are not interesting for us. I only want to say that the so-called fakes, the domestic analogons, often work better than the genuine parts. For example, for LEDs, where HQD sometimes outperforms other vendors. But this is just a side note. For us, important here is this, genuine used. The genuine used field basically constitutes of components which have been desoldered from existing equipment, maybe retinned and reworked, and then redeployed into a new design. And quite incidentally, this is not a joke. Just if you Google recycled electronic components, you even see pictures and links and stories and everything. So please trust me if I'm telling you that this is a realistic issue. And now, of course, the question is, what can we do about this situation? And well, the answer to that is pretty simple, at least for most vendors, such as PCBWay here. You see that they give you a so-called costed BOM, which is a BOM where every individual line is shown the cost for the components. And this is very important because to understand the problem at hand, you need to think like a company producing used parts. And if you can produce this part, which costs nothing, or this part, which costs a lot, then obviously you're going to play with the part which costs a lot, because that's much more profitable and less effortful. And now, to get back to our component at hand, which is this LSM6 guy here. What I like to do is I go to OEM secrets first, put it in here, and then I try to get a feeling for what the price is. I mean, I'm now not saying that we have to get it down to 5% or 10% accurate, but you see, for example, if I'm buying 100, I'm trying to get a feeling, and here I see it's $400 approximately. That's the kind of prices here from the official distributors. And if you are much below this price, it is very, very likely that something is going wrong. And yes, if we now look here, for example, on outsource, we see that there is a used part available at a much lower price. And so if such a price or a price close to this shows up in your bill of materials, it's very likely that something is iffy. And yes, I'm showing here the website of outsource. But I'm not doing this to diss them. Outsource, you see, is very serious. They show the used parts. I'm just using this as an example to demonstrate that these parts really do exist. And you need to keep one thing in mind. People always like to see their contract manufacturer, their PCB house, as this kind of evil entity. But this is actually not what they are. Most contract vendors are excessively polite for a simple reason. It's like when you're looking for a girlfriend. If you try to find a new girlfriend every day, it is a lot of energy invested. Whereas if you have a girlfriend, keeping her happy usually is much less work. And it's much the same for the PCB house. As long as I am happy, I will keep giving them money. So their priority, at least in most cases, I mean there are some criminals, but they exist everywhere. We are now talking about the normal PCB house. Their goal is to keep me happy. And this already brings us to the cardinal rule of TAM number 1. Never put undue price pressure onto your PCB house. If you always queef them up, the price is high, the price is high, the price is high, they want to make you happy, and eventually, such as in the case of my client, they will even suggest to you the use of used components. And this brings us to the second point. If you are aware of the problem of used components, then obviously you can always tell them, please don't use any used components in my PCB. And as we already discussed, the costed bill of materials allows you to easily identify components where it is likely that we will be dealing with a used component. And yes, in some special cases, the only way to work around the problem is, as you see here, sending the components. There are some parts which are just known to be notoriously commonly faked, and if you have an open conversation with your vendor, they sometimes ask you, please slip them in an envelope and send them. I've done this a lot for all of my contract manufacturers in the past with clients that allow me to do it. Sometimes literally I just buy the components off of OEM Secrets, put them in an envelope, write on the outside documents €5 and send them to wherever they have to go. And yes, finally, because some clients are just stupid and demand the use of used components to save money, there are some things which you can do to minimize the risk. First of all, of course, cover yourself contractually. And then, firstly, also perform a risk analysis. Some components, such as MEMS parts, which have moving parts inside, or sensors, are just more sensitive than, like, say, a transistor or something like that. You can also look into the datasheet a little bit and see what they say about reflowing and stuff to assess the risk. And secondarily, after the PCBA, you need to do a QA step, and this QA step needs to be done on site at the vendors, because otherwise you have these crazy shipping costs from the vendor to you and then back to the vendor. And for this, it can be helpful to create a special firmware which runs basically a set of tests and then says go or no go, as to minimize the amount of time which this step takes. And with that, I am very thankful for your attention. I hope you enjoyed this video. I hope you are now more aware of the problems in the supply chain, or rather the potential problems in the supply chain, and can always make a good assessment for your clients. Thank you so much.